Hello guys, welcome to the basic concepts in geography. This video is presented by me, Priya Singh Sanger. In this, we will continue from the Coriolis Effect topic. So, what is Coriolis Effect? Scientifically, when we are observing this, so the role of Coriolis Effect is to express the deflection of moving object in a fluid system or just on the Earth's surface if the observer is in the rotating frame of reference like the Earth. On an Earth, we experience the object in the northern hemisphere deflected towards the right, in southern hemisphere deflected towards the left. The question arises, how much deflection take place and where the deflection take place, and this is given by Ferrell's, and that's what this concept is also known as Ferrell's law. As we know, the earth is rotating, spinning from west to east, and anything which is in the northern hemisphere, it is moving. To an observer on the earth in the northern hemisphere appear to be deflected towards the right, and the southern hemisphere appear to be deflected towards the left because of relative motion. Now, let me discover the Ferrell's law. So, Ferrell's law talked about two things. First, it talks about the formula that give rise to the amount of deflection, and second, it also talked about the direction of deflection. Let's see this. Now, what is the formula? So, formula for the Coriolis effect according to Ferrell's law is 2mv omega sine theta. What is 2mv? So, the m is the mass of the moving object, v is the velocity of the moving object, and the omega is the angular velocity of the earth, and theta is the angle of latitude. Let's we discover the meaning of each. First, we try to understand what happened when the earth stopped rotating or slowed down or speeded up. As we know, the Coriolis effect is directly proportional to the angular velocity. Angular velocity means the rotational speed of the earth, which is nearly constant around 7.24 into 10 to the power minus 5 radians. Now, if the speed increases, hypothetically, then the Coriolis effect also increases. If the speed decreases, Coriolis effect also decreases. If suddenly we assume that Earth stop rotating, then Coriolis effect is also become zero. And this is the all the three cases. So this concept could be a thought in terms of the planetary system. Which planet rotate very fast, and the planet that rotate very fast will have the highest Coriolis effect. The answer here would be what called Jupiter. Jupiter has 10 hours of spin, and the Earth has 24 hours of spin. Which is the slowest planet? So Venus is the slowest planet, so around 116 hours. So now let's see the other parameters in the formula of Coriolis effect. So what does that m means? M is the mass of the moving object. Suppose if the object is more heavy, then the Coriolis effect is more observed. That is the reason that we humans or the animals on the earth is not able to experience it. Does not mean it is not acting. It is acting, but it is high. It is so small, it is negligible. So velocity. Second factor is the velocity of the moving object. If the stronger is the velocity, Coriolis effect would be more and more, because its Coriolis effect is directly proportional to the velocity of the moving object. That's why the rockets or the space launch vehicles, which is rotating at very great speed, has the highest Coriolis effect. And theta is the angle of latitude. So angle of latitude basically deals with the consequences of Coriolis effect on the position on the Earth's surface. If theta is 0, that means at equator a Coriolis effect would be what? Is also 0 at the minimum. As we move from equator to poles, what happened to this Coriolis effect? We know sine 90 is what? Sine 90 is 1. So as a result, Coriolis effect at the poles become the maximum. So that means as we move from equator to poles, Coriolis effect is on increase actually. And the minimum at the equator and the maximum at the poles. That means higher latitude. Remember this fact, guys. In higher latitude, Coriolis effect is highest. Is higher than the lower latitudes. Okay. Now, let's see this. The role of Coriolis effect is what? So the role is to indicate the deflection of the moving object in a fluid system that is observed by the observer on the earth. Now, so the direction of Coriolis or law or the Ferrell's law is given in the northern hemisphere towards the right and in southern hemisphere towards the left. And the right and the left is being observed with respect to the observer on the earth. Suppose if the observer in the northern hemisphere, this diagram representing the northern hemisphere and the bob is or pendulum is hanging or the wind is moving or any rocket is moving. So how does it appear to be deflected to? Just look at this diagram. Suppose observer is here, it is moving, for them earth is spinning from west to east or anti-clockwise direction, so that object appear to be deflected towards the right. Say because the perspective of observer get reversed in southern hemisphere. So as a result, right become left for him. Now where this Coriolis effect is active. So Coriolis effect is active in a rotating frame of reference when an object is thrown and it appears to an observer on the earth in a deflected path, which you can see here. In a non-rotating earth, the path is just a straight one, non-deflected. In a rotating earth, path is appear to be what? Deflected to an observer. Northern hemisphere towards the right, southern hemisphere towards the left. Suppose this is the southern hemisphere. The projectile is thrown like this, it deflects it towards the left. Okay, but in the northern hemisphere, it deflected towards the what called, which direction? Towards the